Okay, so this is problem number 4. So again, I'm just going to go through the steps. So the first step I taught you was to get the first and second derivative. So the first derivative is y prime, and that's going to be, now I don't like how this is out of order, so I'm going to reorder it when I write the derivative. So because this is the higher power, it's going to be negative 15x to the fourth plus 15x squared. And then the second derivative is going to be negative 60x to the third plus 30x. Good. Okay, so now step 2, what I want you guys to do is set the first derivative equal to 0, because again we're looking for maxes and mins, or points of inflection. So negative 15x to the fourth plus 15x squared equals 0. So I can factor out, 15. I'm going to factor out a negative though, so I get that negative out front. So I'm going to factor out a negative 15x squared. So when I factor that out, I'm left with x squared. And then if I factor out a negative minus 1, and that's going to equal 0. So then I know either this is 0 or this is 0. So x equals 0 is one critical number. And then if I have x squared minus 1 equals 0, that's going to be x equals plus or minus 1. Okay, so now I have 3 critical numbers, 0, 1, and negative 1. So what I'm going to do is I'm going to take those, I'm going to plug them into the second derivative and look to see if it's positive or negative, so I know if I'm dealing with maxes or mins. So again, just a reminder, your second derivative is negative 60x to the third plus 30x. So if I plug in 0, I end up with, as we can just see quickly, I end up with 0. So 60, 0 to the third plus 30 times 0. And that's going to equal 0. So again, that's not a max or min. It's probably going to be a point of inflection, but we'll deal with that later. So then we test x equals 1. So that's going to be negative 60 times 1 to the third plus 30 times 1. And when we plug in 1, that's going to give us negative 30, because it's going to be negative 60 plus 30, so negative 30. So because it's negative, we know that it's going to be a max. And then let's move down here. So let's plug in negative 1. So if we plug in negative 1, we're going to end up with negative 60 times negative 1 to the third plus 30 times negative 1. So that's going to be negative 1. So that's going to end up being a positive 60 minus 30, so that's going to be a positive 30. So because it's positive, we know it's going to be a min. And again, we've talked about why. We're not just, I know of course you can memorize the negative is a max, the positive is a min, but we talked in class about why that's the case. So make sure you know that as well intuitively and not just memorization. Okay, so now we're not going to deal with this one for now. We're just going to deal with our maxes and mins. So we know we've got a relative max when x equaled 1, because we ended up with negative 30, so 1. Then if we want the y coordinate, we plug it into the original. And when we plug that in, we end up with 2. So there's a relative max at 1, 2. And then we also know that we have a min, so we've got a relative min. And that's going to be located at, it was when we plugged in negative 1, so negative 1, and then to get the y, again, we plug negative 1 into the original, and that's going to give you negative 2. So now we have our relative max, our relative mins. So now what we're going to do is look for our points of inflection. So that's step 4. So what I want you to do is set your second derivative equal to 0. So negative 60x to the third plus 30x equals 0. So again, I could factor out I could factor out a negative 30. I always like to get the negative out front because I don't like to deal with it in front of my x. So this is going to give me, 2x squared? And then minus 1, that equals 0. Oh, I want to factor out a 30x, not just a negative 30x, not just negative 30. Good. So then we end up with this, of course, x equals 0. And then our other option here is, 2x squared, and then add 1 to both sides. Minus 1 equals 0, so 2x squared equals 1. So x squared equals 1 over 2. So take the square root. Plus or minus 1 over root 2, but then we don't want to ever leave it with a radical in the denominator, so we need to multiply by root 2 over root 2. So that's going to give us x equals plus or minus root 2 over 2. So these are our critical numbers for the second derivative. Most likely they're going to be our points of inflection. So what we want to do is right now we're going to draw our sign chart, and then we're going to see if they are indeed points of inflection, and then we're going to get the ordered pair for it. So let's say we're going to, 0 is 1, and then negative root 2 over 2, and then positive root 2 over 2. Now, just so you know, negative root 2 over 2 is approximately negative 0.71, so this is positive 0.71. Okay, just so that it'll make it easier for you. So if you plug in a number to the left of this, to the left of negative 0.71, well, we already actually kind of plugged one in when we plugged in negative 1 over here. So we ended up with a positive number, so this is going to be a plus. And then if we plug in a number here, you could plug in 1/2. And if you were to plug in 1/2, again, you're plugging into the second derivative. You're plugging numbers in here into the second derivative, not the first, not the original equation. I mean, not the original function. Okay, this is actually going to be here. This is going to be a minus. It's going to be a negative number. And then if we plug in something like positive 1/2, we're going to end up with a positive number. And then if we plug in something greater than 0.71, well, we already kind of plugged in 1 over here. Where did we do it? Right here, we plugged in 1 and we ended up with a negative number, so this is going to be negative. So we are dealing with points of inflection. So let's get them. 0, comma, and again, we plug it into the original. So when we plug in 0 to the original, 0. And then we're going to plug in negative root 2 over 2. And let's see what we get when we plug in negative root 2 over 2. So negative root 2 over 2. When we plug that in, we're going to end up with negative 7 root 2 over 8. Okay. And then our last point of inflection is going to be root 2 over 2. And when we plug that into the original, we end up with positive 7 root 2 over 8. And just so you know, this comes out to be about negative 1.2, positive 1.2. So now let's go down to graph, and this is the most important part right here, because I want to make sure you understand this. So let's go out. It's negative 1, negative 2, positive 1, positive 2. Just in the interest of time, because I can't go over 10 minutes, I'm not going to label it right now, but you know that you always should. So let's plot our points here. So 0, 0 was 1. So then this is negative 0.7. So negative 0.7 is going to be around here. And then negative 1.2. So that's probably right around there. And then we had positive 0.71 and 1.2. So that's another one right there. And then let's plot our relative maxes and mins. So we've got negative 1, negative 2. Good. And then we've got 1, 2. Good. Okay. So the one thing that I didn't do yet, which was concavity. So quickly, let's talk about where it's concave up. Okay. It's going to be concave up when it's positive. So that's going to be from negative infinity to negative root 2 over 2. And from 0 to root 2 over 2. And it's going to be concave down. Let's see, I guess the best place. I don't really have much room up there. It's going to be concave down from negative root 2 over 2, 0, and then again from root 2 over 2 to infinity. Okay, so now basically what that means is we know that we can look at our sign chart. I think it's easier to see than the way we wrote it, but we know it's positive. It's concave up all the way up until root 2 over 2. So that was right here. We also know that this was a min, so that would make sense that it would go up like this, and then it would still be concave up until it hits here. Then we saw from negative root 2 over 2 to 0, it's going to be concave down. So watch as I kind of flip it to go down. Then from 0 to root 2 over 2, it's concave up. And then from root 2 over 2 to infinity, it's concave down. Boom. And we knew this right here was a max. That's how I knew it's going to come like that. So there you go. There's your graph. And this is really important because these 2 points tend to give people trouble. They tend to think that their maxes are mins. So just notice concave up, concave down, concave up, and then concave down. You knew this was a max. You knew this was a min. There you go.